So there's multiple ways that you can simplify meshes, and I added some options to the software that weren't available before. So if you go to the top toolbar and you go to the second toolbox, the blue one, and you drop down, you'll see some of these options are now in different positions or locations than what they used to be. Now, part of that was to give you a bit more structure in terms of especially the simplification of meshes functionality. So the first one I'll show, because that's the easiest one, is just if you go down, in your current version, you'll have the simplify closed meshes option as well. So it looks like a double integral sign. You'll have it in your current software as well, but it's not working correctly in the current software. So it's working correctly in the next version of the software. So this one is really simple. You take a closed shape, and it can even be multiple shapes. So it doesn't have to be only one shape. You press the button. It will ask you for a simplification number. So you just select a number between 1 and 5 on how much simplification you need. So 1 would be a low resolution, and 5 would be a high resolution, and 3, the default, would be just like the normal resolution. So if you select those, the process will continue by itself. And sometimes you'll find 3 works best. Sometimes you'll find for some shapes 1 works best, 2 works best. So it's not always the same one that will work optimal for that particular application. So I'll give it an X. I'll just call it the name XXX, and you'll see the difference. So what this tried to do is it takes a complex shape like the one we've got there. So if I can show, so this shape was, if you look at the top, it's 26.5 megabytes, and then this new shape that came up that was medium resolution is now 2.13 megabytes. So it simplifies that shape quite a bit. It doesn't work for all shapes, it works for most shapes, but the shape has to be fully closed, otherwise it won't work. So so this one is easy. You guys to go to the top toolbar, you go to the second toolbox, and you drop down to simplify closed meshes, and you select the number from 1 to 5, and that's it. So that's simple. That's an easy one. The one above it is less simple, but I think it's more powerful. So the next one, and that's the way many software packages would simplify their shapes, such as, I know MXWrap's got a function to do this, as well as some of the Tasca software has functions to do this as well. So the way I do this is a bit different to the way it's done in other software packages. So I make use of points, marker points, to make the simplification possible. So I'm going to go through it once just to show the process, and then I'll go through it the second time, and then I think it will be quite clear how the process works. So what you do firstly, before you start, you get yourself a shape. So I'll use my original shape, the complex shape. And you'll see this, well, this function used to be in GEM4D, but in the new version that's upcoming, I updated the function quite a bit. And this is the one that says create a grid in a mesh bounding box. Now, before I continue, I should just maybe explain what the mesh bounding box is. So if you've got a shape like this, and you go to, I think it's save over here, you can save yourself a bounding box out. So I'm just going to save one, so I can load it back and just show you what it is. So if I now load back that shape, you'll see what a bounding box is. All it is just a shape that basically encapsulate that object within the coordinate system. So it will be aligned exactly according to the XYZ coordinate system, and it will be the smallest possible box that encapsulate the full mesh inside that box. Okay, so that's what that is. So that's a bounding box. So what this then does, so let's go back to the function, create a grid in a mesh bounding box. So if you select that option, it will say, select yes to make separate grid for every object, and no to create a single grid for a combined object. So if you've got multiple objects in your scene, you can create a single set of grids that encapsulate all those objects as if it's one object, or you can create a grid for every object individually. So for this case, that's what I'll do. I'll just create one for every object individually. Oh, but there's just one object, so it doesn't make a difference. So the box that now comes up, that's define the bounding box of your object. You can change that size if you want to make your grid bigger or smaller. And you can also define the block size. So I'm going to make a coarse block size just for demonstration purposes. Otherwise, it will take too long. So I'm going to make it 3. So it's going to be a block size of 3 by 3 by 3. So if I now say yes, I'm going to save it as a, so you can select yes to save it as a CSV file, that's new, or you can save it as a DXF file. I'll save it as a CSV file because that's the way I'm going to use it. So I'll just call it XXX. If I now load the markers XXX, I've got a bunch of points that's encapsulating my shape. So the next I would like to do is just remove all the points outside the shape and only retain the points inside the shape. So to do that, you use some of the filter functionality. So I go to markers, marker filters, manual, and I'll say, I want to select my shapes relative to the meshes. Now, if I use the relative to the meshes options, the first two would require that my mesh are consistently oriented in terms of the polygons. So let me show you what it means when I say that. So if you've got a mesh like this, and you go to mesh, and all the way to the right hand side, you go to backface culling. If you check that backface culling button and your object image change, then that would mean that your polygons are actually showing the wrong direction. So although polygons are shown in both directions in most software packages, inherently the polygon actually have an orientation. So if I say backface culling and I say flip polygons, then I'm going to flip the orientation so it's now showing outside. So previously it was showing to the inside, so I saw the opposite walls of the shapes. So I'm now going to flip it, and I see the outside. So if I now take the backface culling on and off, there's no difference. There's no visual difference. So I can use this now to my benefit when I filter data. So I'm going to use these points. I'm going to say relative to meshes and keep the data inside a closed mesh. But if you use one of the first two options, then the data or the mesh has to be uniform in the way the polygons are showing, the direction the polygons are showing. So what this will then do, it will go through all the points and see if the points inside the mesh or outside the mesh, and it will only keep the points inside the mesh. If you're happy with this selection, so what you've got now, if I take the mesh away, is you just have a bunch of points. So when you've got regular points like this, so you can now manually tune this. You can say certain points I don't like. I can manually remove some of these points as if I would like to. So when you've got your points the way you like them, you can go to this function that says block surface builder from markers. So what this will do, it will take each one of the markers, it will create a block from the markers, and then it will remove all the inside surfaces. So what you get is something like this. And if I now take a section through this, you'll see that that there's no inside surfaces. You create all these blocks, remove all the inside surfaces, and all you end up with is outside surfaces for that shape. And that's now a vastly reduced resolution of the shape. But where this comes in quite handy is when you've got shapes that's intersecting, like development going into a stope. You want to model that exactly with that intersection. You can use this option to create yourself a shape that goes directly into software packages like modeling packages such as Map3D, for example. So I'll just go through it once more. So what you do is, where's this? I think I have to go to markers, reset, or maybe I should take the markers away. You start from scratch again. So you take your shape, then you use the function where you create a grid around the shape. We only have one object at the moment, so that selection is not important. That's defining the bounding box. Here I define my grid size. Let's say I'm going to make it 3 meters. So now it's got blocks of 3 meters by 3 meters by 3 meters. I'm going to save it as a CSV file, and I'll just save the file. Then I have to go back to my markers, load that particular file. So we've got to load the file. So now I've got points that's encapsulating the object. Now I remove all the points outside the object, so relative to meshes, and I'm just going to keep the ones. And this is, let's see if this works the way it's supposed to be working. Yes, it's working. It works well. So now I've got points that's inside my mesh. And then what this function then does, it takes those points, it creates blocks around it, remove the internal surfaces, and what you end up with is a blocky shape of that particular orientation. But this works for every example. So it doesn't matter how complex the initial shape is, this one can solve it. The next one I'll talk about is a bit more complex. And this is when you want to build, let's say, for example, map 3D models. So I'm just going to clean the scene. So what I'll do is I'm going to load quite a complex scenario. So structural data, simplify meshes. This is this one. So let's say, for example, you get a bunch of stopes like this, and you want to bring it into a map 3D model. But when you go, but when you take the backface scaling on, you see that these meshes are arbitrary oriented. You can't always say which direction they're going. So you can see if I check the backface scaling on, some of the meshes are showing towards me, some of the meshes are showing away from me, and there's no way of telling. So there's no way you can take this into Map 3D. You first have to clean up the data. Now, to do it manually takes quite a while, but you can do it automatically in the following fashion. So what you'll do, you'll select yourself the center point of a stope. So I'm going to select the center point by just double clicking in that location. That's the center point. I know my interlevel spacing is 25 meters. So I'll set I'll do my step size. I make my step size 25 meters. That is now the distance between each level. I'm then going to do line slipping. But I'm not going to do just one line slipping. I'm going to do multiple line slipping. So I want to have a clipping going through the centroid of every stope from the top to the bottom. So I'm going to select myself an arbitrary large number, and it has to be an uneven number, because if you select an even number, you get two lines, one slightly above and one slightly below the point of selection. So you always have to go for an uneven number. So if I now do the clipping, what you end up with is a clipping going through all these stopes. And you see another complication from these stopes is all these internal surfaces. That's going to complicate the model building quite significantly. So what I'll do is I can just save it and then load it again. But I've got an option that says save and load. So what save and load does, it will save this file, then load it back and remove all the previous files. So it's just a quick way of doing steps like I'm explaining at the moment. So that's what I'll do at the moment. I'll call this one YYY, save and load. So it will save the YYY file and then load it back, and that will be the only file that we've got. So now we've got all these files, all these sections as lines. So it's not a polygons with slices anymore. This is now pure lines. So because you save it out as lines, it's just lines now. But you can see they're all one object. So you want to split them up into separate objects. The way you split it up into separate objects is a function in your top toolbar at toolbox number 2 that says combine connected triangles and lines. So what this will do, let's do it. This will go through all these points, and when you've got points that's connected, it will make it one unit. It will make it one object. So you'll see what's going to happen is this initial one of ours. So let's do it. So the initial one had only one object. The new one that's now created. Let me just take this off. Where's the YYY down the bottom? I don't know where that is now. Well, it's not shown. It's not shown at the moment. Okay, so the new one, you can see there's a whole bunch of colors. I could just make the lines a bit thicker. So you can see there's a whole bunch of colors, and each one of the colors will be a separate object. So now you split it up into separate objects. So that's already a vast improvement from before. I'm going to delete my previous file, so that's not confusing me. So I'm going to remove the previous file. The next thing I'm going to do is I'm going to drape surfaces onto them, because I have to remove all these internal surfaces. You can see a lot of them's got all these, although it's one color, there's a lot of internal surfaces that would confuse any algorithm that you try to run on it. So I'm going to drape surfaces on top of all of it, but I'm going to do it in a very particular fashion. So you go back to your top toolbar, you go to toolbox number 1, and you say, create a surface at the Lonely 2D that's going to be draped onto each one of these objects. But be careful. There's a toggle button, and the toggle button is at the moment it's on. Now, when it's on, what it will do, it will combine all these separate objects into one object and then drape a surface onto it. So that works well when you do a topography and so on. But in this particular case, I need to untick the toggle because I want to drape the Lonely surface onto each object separately. So I untick that, then say create a surface and just accept the default. It's going to say select yes to drape the surface vertically down, or in this case, any one of the two will work. You don't have to have a particular one. I'm just going to drape it from above because this is horizontal slices. Can I just ask that everyone mute themselves that's on the call, please? Otherwise, it's a bit difficult. Let's see if I can mute you. Sergey? You'll see there's a mute button at the bottom. Can you just press the mute button? Sergey? Let's see if I can take Sergey. Okay, I muted Sergey. All right. So I'm going to select yes to drape the surfaces from directly above. And I'm going to call this AAA2, whatever. So what you see what this would do, this is going to take each one of these objects and create a surface that then lies on top of these lines. So now you've got polygons, you haven't got lines anymore. So I'm going to remove the lines. So right click and remove. So I'm going to remove the lines. Now I've got surfaces. Now I want to get an outline for each one of these surfaces. So then it's going to be, remember the previous lines had internal lines as well. Those internal lines are now gone. So what I can do, go to top toolbar, go to the second toolbox and say, where is it again? You say extract mesh boundaries and edges. So you go for extract mesh boundaries and edges. And in this case, you only want to extract the mesh boundary. So you go for no to only the mesh boundaries. So you only want to extract the boundaries, not any internal surfaces, only the boundaries of each one of these meshes. And I'll call it AAA3. And you'll see what this thing does is it takes each one of these shapes and it takes out the outline of the shape. So now I've got the outline for the shape and all the internal surfaces are removed. So what I can do next, I can extrude these shapes to represent my previous stopes. Now to do that, I need to know my orientation of my dip of my ore body, and I've measured it before. So this ore body dip, if you do a measurement across like this on the original mesh, you'll get a dip in a dip direction, and it's roughly 70 in the direction of 170. So I know that from before. So when I do the extrusion now, I'll go again to top toolbar, the second toolbox, and there's an option extrude lines or mesh surfaces. So I'm going to select that one. I'm not going to do it normal to the best fit plane. I'm going to define the orientation. So I'll define the orientation, and the dip angle is going to be 70, and the dip direction is going to be 170. And the distance that I select is the distance between my levels, and that was 25 meters. That's why I put 25 meters in the step size. So I have to put 25 here as well. I want to center the extrusion, because if I don't center it, it's going to go from the line and extrude it downwards or upwards. But I want to extrude it downwards and then bring it back halfway. So it's again in the center of the stope. And I'm also going to check the vertical extrusion, because this 25 meters is vertical from the Z elevation is 25, but across a 70-degree angle, it's more than 25. So when you tick that box, that will automatically make that correction for that for the dip of the ore body. See if I say yes, and I'll call this AAA4. I think I haven't used that before. So what you see what happens now is each of these lines are now extruded as a tube. So you'll end up with a bunch of tubes like this, which is open on the top and the bottom. So you can look through them. They're not closed yet, but that's close to what we want to have. So there's only one step remaining, and that would be to repair holes in the mesh object. So this will go to each object and look for holes and then repair those holes by closing them up. So I'm going to say repair. I'm going to select the arbitrary large number, 200. Select yes, and it will ask you for a file name. And the new file that it creates, it takes a while, is now a file where each of these objects have been closed. So the latest option is now back to the original shapes, very close to the original shapes. The only difference is that, that the shapes are now closed. And then this you can normally take directly to Map3D, and you can see what it also did. It broke up all those stopes into separate objects, because initially the original file, all these stopes were a single object. So it broke them all up into separate objects as well. There's another step you can that I've omitted that you can sometimes do. So I'm just going to show that step as well. Let me just go back and see which one. I think I can take this one out. I just have to look for the right file. Give me a sec. So when I go back to the file, we've got the intersection line. So that's one back more. So let's take this one out. Let's see if this one is doing it. So what you could have done as well, when you're at this step, that I haven't done, but sometimes it's needed to do that, is you can have a look and see where's all the line vertices. So you can press that line vertices button. And if there's line vertices, I can make this points maybe a bit bigger. If there's line vertices, you can see sometimes they're not equally spaced. So you've got a high definite, like a high density over there and then a lower density over here. So what you could have done is you could have made all those points an equal distance apart, and you do that by going to split lines into fixed lengths. So when you select that button, what it will do, it will run across each line, and I'll just select the number 3 meters, and it will create points that's 3 meters apart. It's 5 I've used, 6. So what this does, it creates lines that's got points that's now equal distance apart, and then you can just follow the process as before. You can see it changes the shape slightly, the shape slightly, but now all these points are equal distance apart. So that's sometimes useful when you build numerical models, for example. So then you just go through the process after this, the same as before. I'll do it just once more. So then you go for extrude. So you say extrude lines from mesh surfaces. That's the direction, 70 and 170. You go for 25 because that's the interlevel spacing. You center it because you want to have it in the center of the stope. And you check vertical extraction because it's along a dip. So that 25 meters is vertical. So it's going to look very similar to the previous example. So this will just extrude it. And then after it's extruded, you just close it again by using that function that repair the mesh. I'm not going to do it again. I'll just show you the function. And then you can repair the mesh, and then you've got your file that can go to Map3D or other packages. Structural geology. Let's have a look at the structural geology side of it. So when you've got development, for example, one way that you can pick up structures, just an easy way, and this is just for picking up structures underground. What you could do is you can use this function, what I call the map disks function, which is on the top toolbar. And in this particular case, you will use 2 points. You'll say 2 points. You have to define the dip angle. So let's say the dip angle is 60 degrees. And the extension means I'm going to pick 2 points, and it will extend it from those points by 5 meters. So for example, if I now say I want to create a map disk, I pick up the fault there, I pick up the fault there, then it creates a disk like this. And maybe I pick one up there and I pick it up there, it creates a disk like this, and so forth. So as long as you pick, and you can keep shift in, and then you can do multiple selections. And as long as you pick, it will use those 2 points and the direction that the dip that you specified, create disks from it. Those disks you can then export. You can say save as a DXF and a CSV file. So it will save 2 files, and you can use the same name for both. So if I say XXX1, it will save an XXX DXF file. And then if I just say enter again, it will save an XXX1.csv file. And the power when well, I can just maybe show. So if you now take all these disks away, then you can load the XXX DXF file as a DXF, which is just a shape. But the more powerful way, obviously, is you can also load the CSV file as mapping data. And then you can display it as a disk. You can scale it to the original value, and you've got your shapes back from before. So these shapes are created from the information that you loaded in that box. that was saved out by the previous option. So this is a very simple way of doing it. So I'm not going to go into the details of this one, except if there's questions. The next option that you can exercise, and there were some questions about it that came with via internet, is sometimes you want to load an image. So the image that you load could maybe be an OBJ file from photogrammetry. So let's load an example, underground OBJ mapping file. Now this is the best example for mapping you can imagine, but let's use it. Let's use this one as an example. So let's say you load a file as a mapping file. Now sometimes when you load a file with textures like this, sometimes having the shading on is not ideal. So you can go to settings, and the shadings that's currently flat, you can put the shadings off. And then that's sometimes easier, and it's easier to follow. So you can decide if you want to have the shading on or off. When you don't have a texture on your image, you have to have the shading on. Otherwise, you basically can't see what you're working with. So let's say I've got a surface like this, and you want to do some mapping. So let's do some mapping on the surface. I'm going to use the same tool. In this case, I'm not going to use 2 points. I can use 3 points. But let me show you the benefit of using n points, meaning you can select points as long as you like. So I'm going to use n points. You see, then I don't have to make any selections. They're all gray out, except the resolution of the disk that's going to be created. So I'm going to start creating disks. I'm going to push in Control on my keyboard, because then I can, even though I selected an option, if I put Control in, it disables the option for a while, and I can reposition myself. And then I'm going to use Shift so I can do multiple selections. Sorry, I missed at that point. So let's start with the surface. So the way this mapping tool works, it takes the first point, the second point, and the last point. And all the points in between just make the disk bigger. So let's say, so I'm going to use the first point. So I must make sure my first point is a good selection. The same with the second point. All the points afterwards is just making the disk bigger. So I can extend the disk. But I can go back to a point close to my original point and fix the location. I can use Control, look at my location if I'm happy with it. If I don't happy with it, I use a different point. And this one is maybe a more accurate representation of that surface. I can go maybe slightly left if I think that's going to be beneficial. And the moment I'm done, I can right click, and there's my surface, and there's my first mapping point. As you do the mapping point, you also get a point on your stereo net down the bottom there. Okay, so let's do a few more. I'm going to delete this particular one for a moment, because let me show you how you can even do something like that line, which is not a surface, but there's enough differentiation on that line that you can actually also put a plane into that surface down there if you would like. So I'm going to say create N. I have to make sure of my first point, so I'm going to zoom in. I'm going to use that point over there. My last point, I'm going to select all the way over here. And now I can click surface points, and then I can start zoom in on the exact location where I would like, or where I think that will give me a good representation of my surface. So using the first point, the second point, and then the last point is maybe not the ideal way to do it, but it allows you quite a bit of flexibility to fine tune your surface that you select, to make small changes in the orientation until you find one that you feel is fitting that particular plane quite well. And there's the disk. And as before, you can save it out as a CSV and a DXF file, so you can use it afterwards again. I'm going to load some data from mapping on a paper copy, on a paper plan. So I'm going to load the development, and you can see this development looks funny. And the reason this development looks funny is because previously I put the shading off. So if I put the shading back on, then it looks more familiar to what you're used to. So if we now want to incorporate some image data into the scene, you can go to your image object, image. You can bring it in as a normal JPEG file. So I'll say I want to load a JPEG file. I'm going to load this development file. It's going to ask me just as a start, how big should I make the file? It's 50 meters at the moment, so I'm going to accept it. So there's my file. So what it will do, when it brings up an image, it will always put it in the center of the scene, slightly above the meshes that you've got in your scene. So that's the default way it brings it in. So what you now need to do is you need to scale, rotate, translate this image so it fits into the scene. So let's have a look. Now I normally do it in that order. So I do scale, rotate, and then move. So scale, rotate, and move. Move is also called translate. So if I say translate, it's the same as move. So I first going to scale it. It's easy to scale because I know the distance from that point on my coordinate system to that point is 50 meters. So I can say pick a known distance. Pick a known distance. And I'm going to pick that location, that cross point, up to that cross point. And in my scene, it's 23.73 meters, but I know the actual value should be 50. So I put the actual value in it. Okay. What happens is that gives me a scaling factor. So you can see the scaling factor has changed. Nothing changed in the scene yet, but the scaling factor was now set by this pick known distance. Now I will say scale the mouse on pick. So the one that I'm going to pick is going to be scaled. I don't want to scale the mesh. I only want to scale the image. Okay, and my image is now correctly scaled. The next step is I want to rotate my image. And from my coordinate system, I know if I go from left to right, that is actually going towards the south. So in this case, it's easy. I can just change the degrees to 90 and go on because I know I have to flip it by 90 degrees. But you can also, if it's not as well or yet aligned to your axis system, you can say pick known direction. And I can say, okay, I'm going to pick the same points as before because I know if I do it from that point to that point, it should go south, which is 180 degrees. At the moment, it's 90. It should not be 90 degrees. It should be 180 degrees. Okay. And you'll see that changing this direction is now basically put on 90 degrees. The real actual perfect number would have been 90 if I did it perfectly. So that change in degrees is 90. Same as before. Rotate on mouse pick. And I rotate it and now it's in. So it's now scaled correctly. It's rotated correctly. All I now have to do is put it spatially in the correct location. So I'm going to move. Before I start, I'm just going to move it out by 20 meters. I just want to give myself some space so it's easier to connect the points. So what I want to do is I want to connect that point in my image to that point in the scene because those are the same points. So you go for a 2-point offset. You can also pick a coordinate. So if you know the exact location on a coordinate, you can say pick coordinate, select the coordinate and put the numbers in, and that will work as well. But I'm going to go for a 2-point offset. Put control on my keyboard so I can zoom in, select the point, zoom out, go to the location where I want to put it, and that will give me the offset vector. So now I've got the offset vector. The logic stays the same between all these functions. Move mouse pick. So you just pick it, select the object, and it moves it in location. And you can maybe, I'm going to say reset to make it all 0. And then I'm going to drop it by a small amount. Yep, and that's it. And then you can see you've got a clear match between your wireframe and your image. So now it's spatially correct. Now the next time you load it, you don't want to go through this whole process again. So what you then do is you say save and export files under the image options, and you say save this as a Basrock image BRI file. So I'm going to save it as a Basrock file. I'll call it something else, AAA. And what's good about this, if I now delete this file, I can go back and I can say load and import files, load the BRI file, this AAA file I just created, and it will come back exactly where it was before. Okay, so now it's spatially correct. Then the next step is you just want to do some mapping on the image, and that's for that you use that same function as before. So I'm going to have a look around and say, okay, how many is so what's quite common? Now 45 degrees seems to be quite common, and 80 degrees is quite common, and 45. So I'm going to start with 45. I'm not going to do lots of mapping, just a small bit to show. So I'm going to say settings. So there's mapping tool settings. I want to do with 2 points. The angle dip is 45 because I'm going to start with the 45 ones. I'm not going to extend it. So if I pick from one point to the next point, there's no extension. It's going to be exactly those points that's used. And I can change, I can set on the color. So I can do each set, I can give it a different color, except I'm going to put in control on my keyboard so I can reposition my, it doesn't make a difference yet. First, create map disks, put control on my keyboard, reposition myself. And if I now go from left to right, it will dip away from me, and I keep shift in because I want to do multiples. So I keep shift in and I go from left to right, and I will dip away from me. If you go right to left, it will dip towards you. And now you just start filling in. So you say, okay, so where's all the 45s? So that one is dipping towards me. So I go right to left. This one is dipping towards me. It's going to be right to left. And I'll do one more. That one's towards me. So it's right to left. And so you continue on until you fill in your whole data set. When you're done, you just say save as a DXF and CSV file. And that CSV file you can load as a mapping data type. The next thing we'll talk about is warped surfaces. There was quite an interest in questions about warped surfaces as well. So let's have a look at warped surfaces. So I'm going to clean the scene. So let's say you've got some marker data. So I'm going to load data first as marker data, and then I'll load it afterwards as mapping data, because you can use both, but the one is actually better than the other one. So OBJ, where's this? Draping Prism. I'm just looking for the right file. I thought I put it out. Warped surfaces, there it is. Larger. So let's say I've got some data points like these, and I'll just play this bigger point so it's easier to see. 20. So let's say I've got points like these, and you want to create a surface through the points. Now, when you use markers, it will only use the coordinates, because marker data don't have any orientation connected to it. It's only points. So I can go to marker actions, surface, and I can say planar surface. So what this will do, I'll just accept the default. This will create a planar surface like the best fit surface through those points. But the other option you've got is a warped surface. And if I select the warped surface, it will create a surface through the points that's warping according to those points, which is quite beneficial. So when you do your geotechnical faults on a site, or you do your geological faults, you never save the wireframe, you save these points. So you create basis points that you've got confidence in, and then you use the points, and you can easily create a new surface. Because what you can do now, when you've got the points, if I just delete the surface for a moment, you can decide and say certain of these points, I'm going to remove certain points. So maybe you find this point's not accurate, that point's not accurate, that point's not accurate, that point's not accurate. So you can hide, you can selectively take some of the points away, or you can selectively add some points, and then you just recreate your surface. Because creating the surface is so quick that's not the bottleneck anymore. So keep a data set of a fault, and then you can always add new points to the data set or take points away from the data set, and in that way update your fault. So you can use that same, so you can use it as points. So in this case, I use it, so this is only using points data. But what I can also do, I'm going to reset the data, create the surface. Or maybe I'll remove the surface for the moment. Otherwise, I'm going to confuse the discussion. I'm going to load the same points, but I'm going to load it as marker data. So what's the difference? The difference is, because these are now marker data, let's do it. These are now markers, they can have an orientation. So if you use that surface function with the mapping data, it will actually take account of the orientation and adjust the surface according to the orientation. And the bigger your disk is, the bigger the weighting of that point. So a bigger disk have a bigger weighting, and a small disk will have a small weighting. So if you've got 2 points close together, and the one's a big disk and one's a small disk, the algorithm will give favor to the big disk. So you can create your warp surface, and you can say that will take a bit longer as well, because there's a more complicated calculation that needs to happen. So if I use this surface and I compare it to the surface that's coming from the marker points, you'll see they will be slightly different. So you can see there, the two surfaces don't coincide. And you can see the one that's done on the mapping, the top one, is conforming to those orientations that's connected to the mapping data more closely than the one that's just from the points where the orientations weren't taken into account. Maybe one of the last things we'll talk about, I had some questions about Prism data. So let's look at some Prism data. And this is also a good example when you look at the Prism data to show how you can combine marker data and mapping data to get an image that's more comprehensive than any one of these individual ones would have been able to help you with. So what I'm going to load is a bit of a wall, RQD mapping Prism wall. So it's a bit of a pit wall. It's not the full wall. It's just part of a pit wall that failed. I won't disclose the location. So I'm gonna load some Prism data as marker points. What's the benefit of loading it as marker points? When I load it as marker points, I've got options like isosurfacing, and I got options like color coding the mesh and all this stuff. So let's have a look. So I'm going to show it as points. And let's color code it on column number 5, which is the millimeters of movement per day, millimeters per day. So it's column number 5. So at the moment, the colors are the wrong way around because red is small values and blue is large values. So I just have to reverse the colors, reverse colors. So now it's the correct. Large values are red and small values are blue. So that's good. What's good about the marker data set is you can now have isosurfaces from these values. So that's quite quick and it all happens behind the scenes. Or you can color code the mesh based on these values. You just press the button, it all happens behind the scenes. I'm not going to explain how it happens. What it does, it creates a block model in the background that you can't see. So you can see it creates this block model. And then it uses the block model to create the coloring. All right, so but that all happens behind the scenes. Now, let's say you want to highlight this area that's moving quite a bit more, because at the moment it's yellowish. You want to make it more reddish. You can change. So at the moment it's in auto mode, meaning it will go to that column number 5, It will look for the smallest value and the biggest value and then color code in between. But I can manually change that values by going instead of auto mode to manual mode. And then I can say I want to look at all the values between 0.1 up to 0.7, for example. And then I want to update my mesh. And now you get the following image. So now that gives a good indication of where the movement's taking place, where the movement's not taking place. But what you haven't got is the orientation. It's the alignment of these movements. So now I'm going to load the exact same data set as mapping data. So let's load that exact same data set as mapping data. And I'm going to show that the visual I'm going to use is an arrow, is a dip arrow. So there's an arrow. I'm going to set my settings the same as before. So I'm going to reverse the color because I did it in the previous one. I'm going to go for manual coloring. And I'm going to go for column number 5 because that's the column I've been color coding on. Is it 5? 5 millimeters wise. Shouldn't I reverse? This one's reversed, this one's not reversed, but the colors doesn't align. I'm not sure why that is. Something is different. 5. I'm a bit confused at this moment. I'm doing something and it's a simple thing and I can't imagine what it is. So okay, data column number 5. Something is wrong because it should have given me values. I'm not getting the what's confusing me, I was in manual mode and not in auto mode. So it's not auto updating the way it should be. So now I go to auto mode. Now it will be correct. So the error was my error. I was not in automatic mode. I was in manual mode. So I have to reverse the colors. Now I go to manual and I go from 0.1, set it the same as before, to 0.7. So now these colors are matching between the points and the arrow and the arrows. And now you learn quite a bit from it. You can see where the movement's taking place. You can see the direction of the movement taking place. You can see on this wall, it goes along the wall and then it pushes out when it comes to the toe of the wall. So you learn quite a bit from that whole exercise. Because you load it as mapping data, you can also look at the orientations on the stereo net. So that's just, and you can, it's not structural data, but there's some common properties as what you've got with structural data. You can sometimes just from dribble data create yourself a warp surface, like what you're talking about as well. So let's do it, because I haven't done this example yet. So let's use this design example. So I'm going to color code my my image. Just reverse it back and then make it smaller. So okay, please can you just maybe mute yourself, and then when you talk again at the end, we can put you back online. It creates a bit of a rush on the line, please. Thank you.
Hello?
Yep. Okay, so then you've got a data set like this, and when you spin it around, you can sometimes see there's some clear indication of structure in your data set. Now, there's different ways in which you can highlight those structures, because if you look at it at the moment, you can see it, but it's not as clear as it could be. So there's different ways that you can play with your data set to bring out those features quite a bit more. So one way would be to play with your transparency. So if I play, I'll take the mesh out because I'm not going to use the mesh for this discussion. So by just playing with the transparency, you sometimes get a better image of what you're looking for, because you can now match things up. You can see it becomes a bit clearer. So transparency is one aspect you can play with. Another one you can play with is the size of the points. So you can make the points bigger and smaller, and that could sometimes help. Sometimes smaller is better, sometimes bigger is better. Another aspect you can play with is the color coding. So if I change the color coding, for example, and I don't start at 0, but I start at 0.5, then you'll see this come out as a bit red. But the red and the dark blue doesn't contrast as well as you would like it to be. So I find if you sometimes make the top color a higher color than the actual color, you get a better differentiation. So now you can see, look at this. Now you can see the fault zone very cleanly in the rest of the data set. So let's say you want to use this now to create a fault plane across the data set. All you do is you go to the top toolbar, you go to the marker points, and you're going to create yourself some, I'm going to create 3D spheres. And I'm going to make it quite big so I can see them. And I'm going to make them a different color to the rest of it. So I can make it dark blue, because dark blue is not part of the color scheme I'm using at the moment. And then all you have to do is go into parallel view mode. So parallel view mode means things at the back is just as big as things at the front. So you haven't got perspective distortion. And what you do is you align yourself according to that fault plane. You go to this tool, you say create marker points, and then you select yourself some points. That's defining that structured plane. You can reposition yourself, you can use those points now as guides to help you, and you can define yourself some more points along this plane. If you make a mistake on a plane, and you don't like the point that you select, you maybe had a bad selection, you just go back there, say delete the marker point, and then you can click on the marker point, delete it, and then reposition yourself. Align up those lines again. Go back, create points. I want to create a point there, there. And now I go to a last orientation like there, and I create some more data points. Okay, now I've got quite a few data points. Now I want to create a surface through those data points. So what I need to do is save this out as a CSV file. So save as DXF and CSV. I'll call this file XXX. So it's going to save it out as DXF and then save it out as CSV. Okay, so let's do an example. Let's see if I understand correctly. So I'm just going to load some development. So I'll just do one. Okay, so let's see if we've got development such as this.
Yeah.
I'm just going to do a horizontal plane through this. Then you can do it more. So I'm just going to do the HR, those sections that's intersecting at the moment. Or maybe I should use a flatter surface. Let's go for a flatter one. Let's do this one. Yep, so let's do this one. So how do you do it again? You go here, you say radius factor on the grid plane. Yes, to calculate on the okay, this is the new version that's doing it differently. That's maybe part of the reason that I'm struggling with. So you've got points. So it's gonna save some points, XXX, that you have to load back as markers. Okay, so now you've got marker points on the mesh, and then you just have to do the marker points. You do it on the data, so you put it on color number 1. In this case, you reverse the color. So that's what you get. So it's not showing you deformation, but it shows you where you would expect deformation. So let's take this one. Yeah, so let's say for this, you color code the mesh accordingly. So when you color code the mesh like this, is the resolution of the mesh. That means how many vertices on the mesh. So it means how fine the mesh grid is will define how well your representation. Because the coloring actually only takes place at those mesh locations, at the vertex locations. So when you've got a very coarse mesh, the whole mesh will just be gradually scaled from one point to the next. So what you sometimes have to do, there's an option there that subdivide lines and polygons. So sometimes when you want to color code a mesh and you want to have a high resolution outcome, you first have to subdivide the polygons in the mesh before you color code the mesh. Otherwise you get a very coarse outcome because the coloring only takes place at the vertex locations. Okay, let's create an example. I haven't got an example, so I'm going to create an example. So I'm going to create this grid. So let me just maybe go and just highlight the colors a bit better. So I'm going to say 1.2 and then go to 2.5. So I'm just creating a... Okay, so I'm going to use this grid. So I'm going to just for something to use. So I'm going to export it as a... How do you do it again? You go for mesh, markers, you say regular grid, and then there's an option to say export. Other options, regular grid points. Okay, so I'm going to save these points. So I'll call it XXX. Okay, and then I'm going to load these points. So grid points, and I'm going to color code on column number 1. All right, and then I'll take out the bit for the moment. So let's say I've got a number at the points like this, and you want to make it look nice. So there's different ways. So in 3D, what you can do is you can change these points so it looks like 3D points. So it looks like this. So that makes an improvement already, just going like that. Another way to do it, you can go to a particular line and you can do a clipping through that line. And then if you do a clipping through that line, you just have to be, you always, because these points will be the same size. So if you zoom in, they look smaller, and if you zoom out, they look bigger. So you always play with your, so if you want to make a good image, and I can just maybe go back to the square points, then you can play with your size until you get the image that you like. So if you go oversize, then it looks like a solid block. If you go slightly undersized, then it looks like there's small lines through it. Or you can go for these points and then make it a bit bigger as well. And then you can have like that type of look. Or you can make it a bit smaller and make it like individual points.
Okay.
Is that what you're asking for?
Yeah. Fine.
Yep. And then you can also, on top of it, you can also make it transparent as well.
Okay.
So you can play with your transparency to make it less. Yet sometimes it's useful. Let's say, for example, let's bring the pit back. It's not an underground scenario, but at least it will show you. Yet sometimes it's useful when you've got the development outline as well to make it a bit more translucent, so it's not as in your face. So it just depends on the circumstance. And then you always have to be careful in your selection of your colors, because people always associate red with bad and blue with good. So you just always have to make sure that you do show the colors in such a way that red represent the bad case and blue represent the good case.
Okay.
Because people actually, people pay attention. And I always, what I would sometimes do as well is, I'm really concerned about something, I'll make it very obviously red. And if I'm not really concerned about something, I will not use red at all. I'll maybe use yellows and greens, because that image is quite powerful. And the way you represent that image sometimes create a perception on what they think they should understand from the image. So it's quite important to use the color sensibly. So to create a section, you use on this right panel, there's clipping. So you go to clipping, and then there's different options. The first three is it's easy. It's easting, northing, and horizontal. So horizontal clipping is exactly what it says, horizontal clipping. And it could be an open polygon, it could be a closed polygon, like this, if the wireframe is closely connected, or it could be lines. All right. So you can do a single clipping like this, which is now horizontal, or you can make multiple clippings like this. And the distance between those clippings is set by the step size. If you make the step size smaller, then the clippings are closer together. And if you make it bigger, they're further apart. Okay? So I'll go for one clipping again. So that's horizontal clipping. That's easy. If you want to do a vertical clipping, you select vertical. And then you're just going to select 2 points. And then it will create a vertical section between those 2 points. So that's the way you do a vertical clipping. So you guys go to vertical. So vertical, clipping, pick 2 points, and that will create a vertical section. If you want to save the section, if you want to have a copy of the section, you just save it. So my clippings isn't a visual, it's just not just a visual clipping, it's actually a physically new object. That's why it's a bit slower than other packages, because it's not just a visual clipping, it's an actual new object that I create. So you can save this object, this clipping, I'll call it YYY. And then if I now go and I load YYY, it's not the pitch shell anymore, it's just a line.
Okay.
So you can always go and save it back. So if I load the pitch shell back, just to show the other options. Another option is creating a plane by 3 points. I'm just going to go in perspective view. So it's 3 points. So you have to pick 3 points. So if I pick a point and a point and a point, it will create a section along those 3 points that I've selected. Make sense? So it's just 3 points, and it creates a section along those 3 points. Then there's another way you can do it. You can do it along the camera view. So if you look at it like this, for example, and I say camera, if you use the camera view, so what this one does, you select 2 points, like a point and a point, and then it's going to create a slice from your point of view. So if I do it, you'll see it creates a slice along the camera view. Okay, so what you can do, so there I've got 2 pitch shells. And let's say I want to transform this pitch shell to that pitch shell. So I want the 2 to match perfectly. I'm going to use, you can see there's spikes that I put on the pitch shell, so it's just to make it easy. So I want to make the green shell to match the yellow shell. So that's what you use this transform option for. So what it says is you start with the coordinates to the target. So what's the coordinates that you want to target? So the coordinates I want to target, pick 3 coordinates. Is that coordinate, this coordinate, and that coordinate. So I want to have the top of that, what do you call it, that cone and the top of this cone. So I can't just pick, because now it's going to pick at any place in between. What I first have to do, I have to select the snapping that snaps to the vertices of the points. So let's do it again. I'm going to pick 3 points. You'll see if I now click on that surface, it will snap to that closest point. This one will snap to the closest point, and it will snap to the closest point. So now that 3 coordinates are locked in. Now I go to the one that I would like to transform, this one. I do the same thing in the same order. I want to take this point, and that point. So now I've selected 3 points on my target and 3 points on the object that I would like to transform. So I accept and pick object. So if I accept and if I now pick this green object, it's going to use these values to try and transform it onto the other value, onto the other one. And you can see that's exactly what he did. So the green one is now overlain on the yellow one. So it works in most cases, but not in all cases.
Yeah, that's a good feature. Thank you very much.
Yeah, I'm not going to promise you it's going to help. It's going to work in every occasion.
I should try that one.
Okay. That's good. So let's do the coloring. The coloring is easy. Let's do the coloring.
Yeah.
So what I'm loading, I'm going to load 2 shells, 2 pitch shells. The one is an actual and the one is a design. Okay. So it's 2 pitch shells. an actual and a design. And I want to color code the actual on the design, so I can see where it's overbroke or underbroke and all that type of stuff. That's what you want to do, is it?
Yeah, yes, yes, yes.
Okay. So you go to the top toolbar, and then you go to color palette number 1. So these color palettes will only color meshes. It will not change or create a new mesh. It only colors existing meshes. These two buttons, these two with the toolboxes on it, they will actually create new objects. Okay, so there's a difference. So I go to this one and I say color on the closest distance from a mesh. Okay, so I click that one. Now you have to be careful. If you say -5 to 5, it means there will be a differentiation. So if it goes to the minus side, it's going to be one color. If it goes to the plus side, it will be a different color. If you say 0 to 5, then 5 in any direction will have the same color. So then the direction is not important. So saying -5 to 5 or 0 to 5 is giving you a different outcome. So I'm going to say I would like to look from -2 to 2. Accept. And then I'm going to click on the one that I would like to color. So I'm clicking on the one that I would like to color. So let's see how that looks. So now you get the following. So I'll hide the design. So you see anything that's behind the design is dark blue. And anything in front of the design is dark red. So now you can see, so all the dark blue is underbreak, and all the dark red is all the dark blue is overbreak, and all the dark red is underbreak. Yep. Happy with that?
Yes, yes,
So
yes.
you just
Very
load
up.
the two meshes. You go to that first option. You say color on closest distance from mesh, and then you just have to select a minus value and a plus value if you want to differentiate between the back of the polygon or the front of the polygon, which
Okay.
means underbreak and overbreak in this case. Yeah. I think there was one question
Yeah.
that I missed. Is someone asked me how to drape an image in GEM4D, how to drape an image onto a surface. So let me just
Yes.
show you. Let me just show you that one. I think I've got an example here somewhere. Let me just have a look. Draping. Yep. That's topo drone, topo survey. Let's use this topo survey. So let's say you've got an image like this. Then, as I explained before, you can then load an image and you can scale and rotate it and put it spatially correct. So I've done this already. So surface, drone, surface. I'm going to use this one. So there's the surface and it's spatially correct. So when you've got when you've got your mesh and you've got your image spatially correct, scaled, rotate, translated correctly, all you have to do, you say image actions, drape image, click on the image, and the image will drape onto the surface. So what's nice about this, if you spatially orientated any image, you can then go and drape it onto any surface immediately. It's easy. So what's nice about this, so I don't connect the surface to the mesh. I keep the surface separate because it's already you just load the image and then you can drape it onto any surface thereafter just with a click. You can save this though as an OBJ file. So there's an option to save and export. And you can save it as an OBJ file if you would like to. So this you can save as an OBJ if you like. But I normally just keep it as a Basrock image file, which is spatially oriented, and then I just quickly drape it onto any surface. So I'll do it again. So all you do is you load the mesh, you load the image as an image. After you spatially put it in the correct location, you save it as a Basrock image file, then you can just directly load it back, and it will still be okay, exactly the way it should be. And then you just say image actions, image drape image, and it will just drape it directly downwards onto any mesh.